All right, this morning our goal is going to be to simplify properties of exponents. So hopefully this is review, and if not, hopefully we'll pick it up this morning. So just a little, each one of these, 5 to the first power, anything to the first power is just itself. So 5 to the first. 1 to any power, 1 to the fifth is 1 times 1 times 1 5 times. So 1 to any power is going to be 1. Anything to the 0 power, 5 to the 0 power here is 1. I'm actually going to kind of explain that right underneath here with the examples with the negative exponents here. And 0 times itself 5 times, so 0 to a power other than 1 is equal to 0. 0 to the 0 power is actually undefined, so we'll talk about that later. Okay, now down here, I want to kind of get into our first property of exponents we're going to review, which is negative exponents, and kind of explain where it comes from. So I just actually want to start on the right end of this and go backwards and kind of explain how this property is developed. So 4 to the third means 4 multiplied by itself 3 times. So this is going to be 64. 4 squared, 4 times 4 is 16. 4 to the first is 4. And as we go along here, hopefully what you guys might notice is each time I back up a step, I am dividing by 4. So divide by 4 here. And if I do that, the reason the next step is 1 is because you're taking the previous step and you are dividing by 4. So, sorry, I should have written that in here. 64 divided by 4 is 16. 16 divided by 4 is 4. 4 divided by 4 is 1. And then this is also where we get our properties of exponents. So it's the previous divided by 4. If you get here 1/4 divided by 4, if you do keep change flip here, this would actually end up being 1/16, which is what I'm going to write down. So this is 1/4. This is 1/16. And if you took 1/16 and divided that by 4, when you divide a fraction by just a number by itself, what it does is it multiplies into that denominator. So this is actually 1/64. And as you keep going, you would keep going that direction. So negative exponent is not a negative number, it's actually a fraction. So that's where the negative exponent rule comes from, which is that if you have, usually use an a as a base to represent these, a to the negative n. If you don't have a fraction within the problem, you want to turn it into a fraction. So a to the negative n, I'm going to turn into a fraction real quick, call it move it and lose it. So you move it to the opposite part of the fraction, and that exponent loses its negative sign and becomes positive. Okay, conversely, if you have a negative exponent in a denominator, then it actually moves to the opposite part of the fraction. This would move to the numerator, move it and lose it, that negative exponent there. Okay, so we've got a couple problems, negative exponents. We're going to simplify. I'm just going to turn this into a fraction, move it and lose it. This would be 1/7 squared. Now, if you don't have a variable, if you actually have a number, and you can go ahead and simplify that number, go ahead and do that. So 7 squared, hopefully we know, is 49. So this would be 1/49. 4 to the negative 3, if that's in the bottom of the fraction, that moves to the top. So this becomes 4 to the third, which we just wrote that up above, is going to be 64. Next one we're going to talk about is the product rule. So the product rule is going to say like bases if you multiply them together. So I'm going to say a to the n times a to the m. What you want to do there is you want to go ahead and add those exponents together. And I'm going to show you what that means in the next example here real quick. Okay, so x to the third would really be x multiplied by itself 3 times, x to the fifth, 1, 2, 3, 4, 5, and if you count all of these, it's just a little bit quicker to add them together than writing all that out, but this is why you add them together, because you have 3 here, 5 here, so I have 8 total. So that's where that property comes from. Okay, now on this next one, just really quick, this is something people mess up all the time with numbers, not so much with the variables, but with numbers. Do not multiply these 2's together. You do not want to do that. So 2, this would be 2 written out 8 times, 2 written out 6 times, so I have 2 to the 14th power. Most common mistake on that question is people will actually write maybe 4 to the 14th power. You do not multiply this. This is 2 written out 8 times, 2 written out 6 times, so you have a total of 14. So do not change the base. Just like we didn't change the base here, just kept it as an x, this stays as a 2. That becomes tricky for people with numbers sometimes. Okay, now next we have the quotient rule, and I don't always kind of follow this, but of course you can. A to the n over a to the m is going to be a to the n minus m power. So you can subtract the exponents, and sometimes that would result in a negative exponent, which then you can apply the negative exponents property. However, what I usually do is what I'm going to show you guys on the next example is I just ask myself the question, where do I have more of whatever the base is? So these are x's here. Where do I have more x's? And I would say the top or the bottom. And hopefully you'd tell me the top. And I'd say, how many more? And you'd say 2. And that would actually be the answer to the question. So let me show you that real quick again. The top of that would be x to the 5th. The bottom would be x to the 3rd. Everything's being multiplied here. We don't have any adding or subtracting. So these 3 x's in the bottom cancel 3 x's in the top. That leaves you with 2 in the top. Now you don't have to write that out, but that's just another way to look at it. Again, here, if you want to apply the property, you could do 4 minus 7. That'd give you x to the negative 3rd. And then you'd have that x to the negative 3rd. We put 3 back in the bottom. Now, to me, it's easier just to say, where do I have more x's, the top or the bottom? Hopefully you would tell me the bottom, and there's 3 more. And so that'd be x to the 3rd, and you just go ahead and leave a 1 on the top because the top of that exists, so you don't want to leave a 0. So if you want to subtract exponents, you can, or if you want to just say, where do I have more, the top or the bottom, and then how many more, that's another way to do that. Now, the power rule, so I call this a lot of the time power to a power. If you have a to the n to the m power, what we're going to do, power to a power, we're going to multiply the exponents together. Again, I'm going to explain that to you in this example here. So this would be n squared written out 4 times. So then we could do our addition property, or our product rule here, just add these up, and that would give us n to the 8th, or it's just a little bit faster to do 2 times 4 and get n to the 8th. Now, the one right next to this is actually kind of a 2-part property. I have a product in here, 3 times n to the 5th, and a squared on the outside. Now, for the 3, I do actually, no adding or subtracting in here, it's a product. You want to distribute that exponent to the 3, and power to a power, I'm going to multiply those exponents. 5 times 2 is 10. And then I can just simplify a little bit here because 3 squared is going to be 9. And that's going to give me 9n to the 10th. Okay, the top of the back side here, just a summary of all the properties we talked about on the front. So you have them all in one place. Anything to the 0 power is 1. If you multiply like bases, you're going to add the exponents together. Power to a power, you are going to multiply the exponents together. We didn't really specifically talk about this except on that last example we did real quick. If you have a product to an exponent, you have to give that exponent to everything in the product. So a to the m there and b to the m. And we talked about negative exponents, so turn that into a fraction if it's not already, move it and lose it. Same thing here, if it's in the bottom, we're going to move it to the top, so this would just be a to the m. This is your quotient. Again, I would just say, where do you have more a's, the top or the bottom, and how many more, and do it that way, or you can subtract the exponents. Now, I know I wrote this differently on the front. I had the n on the top and the m on the bottom. It doesn't matter that I wrote it backwards. What does matter, though, whatever is the numerator exponent, if you want to apply this property, the numerator exponent, whatever's on the top, subtract whatever's on the bottom to do that property correctly. Another one we didn't actually do on the front. Actually, we're going to do it on the back here. This is a quotient. Again, nothing is being added or subtracted here. You do give this exponent out to everything in that fraction. So this would be a to the m over b to the m. Those are different bases, so they each get that exponent. And if that ends up being negative, I'm just going to kind of use a little space here to go kind of backwards. So I would have a to the negative m, b to the negative m, and then those negative exponents are not considered simplified. So these guys would just have to trade places, and the actual property there then would look like b to the m over a to the m. So that's a summary of all those properties. All right, now I just have a bunch of different examples to run through some different properties of exponents, and they're all kind of mixed together, so see what you remember. All right, so this is a product here. You're going to multiply the numbers together, and it doesn't matter what's attached to them. We're not adding. Everything's being multiplied here, so go ahead and multiply the numbers, and I'm going to add the exponents on the letters that are the same. So like basis there, 5 times 2, and then I've got p to the second, so p to the fourth. Now, this can always be tricky for people. Q here, it doesn't have an exponent written in, but it is there, and there's one Q there. So sometimes I like to write that exponent in to make sure I get that done properly. So there's one Q here, 9 here, so you have 10 total, and that would be simplified there. All right, multiply your numbers, add the exponents on the bases that are the same. -2 times -4 is going to be +8. Now here, if I add these exponents, this is x squared x to the -2, that would be x to the 0. So anything to the 0 power ends up being 1, so the actual answer to that question is just going to be 8. Okay, couple ways to do number 3. What I might go ahead and do here real quick is go ahead and give that exponent out to everything in the product. So 6 to the 3rd, power to a power, I'm going to multiply those exponents. Power to a power, I'm going to multiply those exponents, so we're going to get x to the -15, y to the 12th. Now, negative exponents are not considered simplified, so I got to make myself a little fraction here. Only the negative exponent is going to move down, so I'm going to move that and lose that, and I wrote too big. 6 to the 3rd power is 216, y to the 12th would stay on the top, and then we're going to move and have x to the 15th on the bottom. When I move that down, it's going to lose that exponent. All right, here we got a little product, so let me go ahead and in the parentheses there, this will be 2 to the 4th, x to the 4th. Now, 2 to the 4th power is going to give us 16, and then I've got x to the 5th, x to the 4th, so we've got 9 there total. All right. Next one, power to a power, I'm going to multiply my exponents, so that would be p to the -9th. That is not considered simplified because of that negative exponent, so it would be 1 over p to the +9th power. Here, I'm going to go ahead and distribute that exponent, 3 to the -2. Okay, now power to a power. So this is actually going to become x to the +6. This is going to become y to the +4th. But I do need to move this negative exponent with the 3 here, so we're going to move this down. So x to the 6, y to the 4th stays on the top. Now, 3 squared is 9, so I'm just going to go ahead and write 9 on the bottom, but that's where I'm getting the 9 is by squaring 3. Okay, division. Now, 2 over 8. I want to reduce that. And so before I do that though, real quick, let me do the properties of the exponents here with the a's. I'd say, where do I have more a's, top or the bottom? You would tell me the bottom. You'd tell me you have 3 more. And then in terms of this fraction, 2/8 is the same thing as 1/4. So just reducing that like I would normally reduce that. Basically what that does is everything on the top is going to cancel then, because it would just end up being 1. And so I'm going to leave a 1 on the top, and then we should have a 4 on the bottom for that 1/4. Okay, let's do the top of this first before anything else. So we'd have 12 squared, power to a power. I'm going to multiply these exponents, x to the 4th, y to the 12th. Now the bottom of this, 8x to the 4th over y to the 7th. And I should have probably done this here real quick. 144 over 8. And then simplify from there, make it a little easier to do. So in terms of the numbers, 144 divided by 8. Just pulled up my calculator there. Whoops, maybe I did. Okay, so that's actually a nice number. That's 18. So I'm going to leave that 18 on the top because the bigger numbers on the top. These actually have equivalent exponents, so they're just going to cancel each other out. And I'd say, where do I have more y's, the top or the bottom? You'd tell me the top, and you'd tell me 5 more. And I actually do not have a fraction then there because everything in the bottom canceled out. I don't need to leave a 1 in the bottom like I would with the 1 in the top of a fraction. All right. Now I would move my negative exponents around here first, just real quick. There's different ways you could do this particular problem right here. I just like to get rid of the negative exponents if I can, so I'm just going to trade those guys places and then simplify from there. If you want to do this in a different format, you could add on the top and then subtract the bottom. It's totally up to you. This is just how I would do it, and then I would simplify from there. Now, when I move this x to the negative 5th to the top, that's being multiplied up at the top when you move that. So when you multiply like bases, you add your exponents, and I just moved this x to the negative 2 to the bottom. That was the only thing in the bottom. Then I would say, where do I have more x's, the top or the bottom? You would tell me the top, and you would tell me 7 more. All right, I'm going to kind of do the same thing here. This x to the negative 1 is going to go up to the top, and this y to the negative 6 is going to go to the bottom. So I'm going to leave what was there and just move those negative exponents, and then I'm going to simplify from there. Now 3 over 6 would be a half, so I'd have 1/2. I'm just going to put the 2 on the bottom for the moment. Now on the top it would have 1/2, right? I don't have to write the 1, but I do need to write how many x's are up here because they're not going to be canceled at all. So I'm just going to leave x to the 8th. If you want to put a 1 in front of that, you can, but you don't need it. And then on the bottom, how many y's do we have? We got 4 and 6. So we have y to the 10th, and then nothing else cancels out because we don't have like bases there. Like bases just means we have to have the same letter. Okay, now, negative 15 here is not a negative exponent. I'm going to leave that where it's at for 1 second and just move this negative exponent. So don't move a negative number, just move a negative exponent. So I'd b to the 5th. Now that b's going to come down to the bottom and be b to the positive 2. Okay, now negative numbers do not move, so just leave that negative 15 where it is. Negative 15 over 3 is negative 5. I'm going to go ahead and leave that in the top, and I'm going to say to you, where do you have more a's, the top or the bottom? And you're going to tell me you got 2 more on the top. The bottom of this, I have b to the 5th, b to the 2nd, so b to the 7th, and that would be the simplified version. And then I got 2 more here. All right, so power to a power. This is going to become 8 squared. And then power to a power here, x to the 6. I'm multiplying those exponents. Now, everything gets this exponent. So 4 gets squared also, and this becomes y to the negative 4th. Now, I'm just going to move this up, and as I do that, I'm going to simplify a little bit. This is 64 x to the 6th, y to the 4th over 16. The only thing you can actually simplify here is the 64 divided by 16, which is just going to give me 4. And so I'm going to have no more fraction here, just 4x to the 6th, and then y to the 4th. And then last problem, everybody on the top gets a negative 2 as an exponent. So 2 to the negative 2. Now, power to a power, we're going to multiply these here. So negative 1 times negative 2 is actually going to give you 2. 2 times negative 2 is going to give you negative 4. 0 times negative 2 is 0. Okay, so anything, this is, I'm just going to go ahead and write this in here, but this is going to stay z to the 0. Anything to the 0 power is just going to be 1. So effectively that's going to get canceled out. Okay, now the bottom of this is 2, which I'm just going to put a little 1 on that. Okay, now we got x and y. So I'm going to move my negative exponents. Like I told you guys, this just becomes 1, so I'm not going to even worry about that. This guy's going to move down. This guy's going to move down. So on the top, I'd have x squared. Now, this would be 2 to the first times 2 to the second. You have this x, you have a y, and you have a y to the fourth. Okay, so I've got this x squared on the top. This becomes, don't write 4, 2 to the third power. You have 2 coming down here. You already had 1, so now I have 3. You have an x and you have y to the fifth. Now I'm just going to simplify a teeny tiny bit. I have 1 more x on the top. I can simplify 2 to the third power to be in an 8. And then y to the fifth, nothing more to combine that with. And so that's going to be my answer, x over 8y to the fifth.